Today we'll discuss about the buck converter operation. I already said that the buck converter is designed to reduce the input voltage to lower output voltage while maintaining a steady current. In these cases, we can see that the buck converter consists switch, inductor, diode, and some cases also used capacitor to achieve either voltage reduction or allows the output voltage to be lower than the input voltage. Okay, so in case of the function of the each and every component which is used in the buck converter, so firstly, what is the function of the inductor? So inductor can store energy when current flows through it and release its energy when switch is off of the circuit. Next is switch. Switch is used for the control the current flow through the inductor. Diode, the function of the diode, we know that diode can allow the current flow in one direction. Okay, that means it's preventing backflow of current from the output to the input. And load, where the device or circuit that uses the output voltage. So how does a buck converter work? So in case of the buck converter, the operation of a buck converter also occurs in two phases: on time when switch is closed and off time when switch is open. Okay. The black portion of the circuit shows that portion of on state or off state. That portion, the black portion, that means it will be disconnected from the circuit of different state. Okay. So in case of the on state, we can see that the diode is a black color. That means diode is not include the circuit. Okay, that means when the switch is on, when the switch is on, the current flows from the input through the inductor to the output and load. So that means the inductor storage energy in the form of the magnetic field as the current increases, and that means the diode is a reverse bias, and so it doesn't conduct. So that is why the diode is not included in on state operation of the buck converter. So in case of the off time, when switch is off, that means the switch portion is not connected in the circuit portion. That means the whatever the energy storage in the inductor, it is released through the load through the diode. Okay, so the switch is open right now, so interrupting the direct current flow the input. So the inductor magnetic field right now collapse because it didn't get enough current to strengthen the magnetic field. That is why it is collapsed, and at the moment of time, inductor is ready to release its energy, and the voltage across the inductor is reverse forward biasing the diode and the allowing current to continue flowing through the load. Okay. So in case of the buck converter, we know that the output voltage and current waveform, which is shown in the right hand side of the slide. So we can see that the output voltage is same as the input voltage, that is V0 equals to Vs when switch is on during the period of T on greater than equals to T greater than equals to 0. At that period of time, the switch is turned on at T equals to 0 and then turned off at T equals to T on. Okay. So this is the time we can say that on period. So during the next time interval, T greater than equals to small t greater than equals to T on, the output voltage is 0, that is V0 equal to 0, as the diode D now conducts, the off period is T off, which is also calculated T minus T on with the time period. The frequency is 1 by T with T kept as constant. The average value of the output voltage we can see V0 integration 1 by T 0 to T Vs into dt. So after the solving the integration part of this buck converter, we can get the output equation equals to V0 equals to K into Vs. That means the output voltage of buck converter is dependent upon the input voltage and duty cycle. If the value of K equals to 0, that means the output voltage will get 0. If the value of the duty cycle is equal to 1, that means we will get the input voltage equals to output voltage. So we can change the duty cycle value. We can also vary the output voltage level of the buck converter. So normally, in case of the buck converter, its efficiency are generally it is high efficient, often reaching 90% or higher depending upon the design and components we will used in the circuit. So buck converter are widely used in the power supplies for devices like laptops, mobile phones, and embedded system where a lower or regulated voltage is needed from a higher input voltage source. Okay, that is all for today's discussion.